Get recording here. All right. So we'll kind of start on we'll start where we left off in module 11 today. Kind of have that participation quiz. I've actually got, where is it at? Oh, I might not create it yet. I'll have that module 11 quiz pop up as soon as I get back to my office after class as well today. So it'll pop up underneath the module 11 kind of heading. Tomorrow we'll start module 12, so that reading is due before we start class tomorrow. For game theory, I've got all the kind of materials up there, and then I've got those final exam practice materials as well as that hypothetical grade tool. So I mentioned this a little bit yesterday, but I just wanted to kind of go through again. I had something set a little bit weird with this second row. So this second row is showing you the scores that you should be seeing on Canvas. The third row is the one that uses the values that once you input your grades, so you could put in all your module reading grades up to, which, we haven't had the 13th or even the 12th yet, so you can kind of fill those in as we go along. And what this does is this will show you what your current grade should look like on Canvas. Here's what your grade would be after that lowest module reading is dropped. If you put in new module readings, it kind of updates those for you. Same kind of thing with the quizzes. It's got what your quiz grade would look like on Canvas with the lowest 2 dropped. And then participation scores, we still have a lot of those left to fill in, but it would calculate up to this point what your current participation quiz score is, and then with the 4 lowest dropped. Then use those values to come up with what your current grade in the class is. Now, this won't be what you see on Canvas because you can play around with this hypothetical final exam grade. So if I get a 70, what would my score be with the lowest dropped? What would it be without the lowest drop? Now, this isn't really that useful since I do drop the lowest if you're trying to get this hypothetical grade. But kind of showing you how much that grade changes when you see those lowest scores being dropped. And then these numbers should be the ones that kind of match up with what you currently see on Canvas in terms of the group kind of score, quiz scores, module readings, participation quizzes. Okay. If you have any questions about how to use that, please reach out, let me know. I think that should be something useful as we're getting closer to that final exam next Friday. Any other questions for me before we jump back into kind of where we left off with module 11? Okay. All right. So we left off talking about kind of this perfect price discrimination. So I think the examples I gave you, we kind of have this constant marginal cost. And we said when we're comparing a single price firm to a price discriminating firm, we're going to end up seeing that some people, right, that are more inelastic end up paying a higher price, right? Some people are going to be charged a lower price. Those are going to be people that weren't buying before, right, but are more elastic. So when you lower the price, they now enter and buy something in that market. We're going to see the overall quantity of sales goes up, and then welfare is going to increase, and deadweight loss, we said if it was perfect price discrimination, would go to 0. So what did that kind of look like for us? So I'm going to show you a depiction, not using a constant marginal cost, but even if the same thing would apply if we had increasing marginal costs. Okay. So if I think about what we were doing from last class, we had this downward sloping demand curve. Now let's say we've got increasing marginal costs. Okay. We said that a single price monopolist kind of faces this downward sloping demand curve, right? And so for a single price monopolist, what we would see is that profit maximizing quantity is going to be right here. They went up to the demand curve to set the price. Okay. And then we said, okay, where would the perfectly competitive point be? Well, if we have one firm, the firm's marginal cost, that would be all of supply. So our perfectly competitive quantity and price, we're out here. Okay. So I'm going to try to kind of write this or do this side by side. Let me move this mouse out of the way. There we go. Give myself a little more room here. Excuse me. So before we look at a price discriminating monopolist, what did we say is going to happen with a single price monopolist? Well, because they're not producing these units, we lost out on all of this total surplus, or we had some deadweight loss. Now, if we're thinking about what consumer surplus is, that's the difference between the marginal benefits and the marginal cost to consumers. Well, what is their marginal benefit? It's represented by the demand curve. The marginal cost to them is going to be the price. So the difference between demand and the price, here we had consumer surplus from this single price monopolist. What is producer surplus? That's the difference between the marginal benefits and the marginal cost of producers. The marginal benefit to them is the price. Marginal cost, they've got their marginal cost or their supply curve. So the difference between the price and the supply curve for the single price monopolist would be right here. Okay. So if they're instead able to perfectly price discriminate, how is that going to change things? Okay. So I'm going to try to draw these side by side so we can kind of make this comparison. Got my quantity, my price, try to draw about the same place. So demand, here's my marginal costs. We said here's our perfectly competitive price and quantity, simply where supply is equal to demand, right? Now, what's going to happen if we have a perfectly price discriminating monopolist is they won't, this marginal revenue curve, the reason it was twice as steep came from that idea that when we were plugging in our demand equation to that total revenue equation, then taking a derivative to find marginal, that was assuming we were setting one price, okay? So we're no longer setting one price here. At every quantity, we said last class, if I can perfectly price discriminate, I'm going to charge this price for the first unit, this price for the second unit, etc. So really, every price, right, every unit we sell, we're selling for a different price. So we no longer have like one value of marginal revenue. The marginal revenue at every quantity is going to be the price that we're charging, or the demand curve becomes our marginal revenue, PD, for this price discriminating monopolist. Okay. So now where would marginal revenue be equal to marginal cost? Well, notice the quantity that the price discriminating monopolist gets to, perfect price discrimination, would be the same point as the allocative efficient or that perfectly competitive quantity. So what should be true at the perfectly competitive quantity? If it's allocatively efficient, we should see total surplus be maximized, right? We're no longer seeing the number of units being below that allocative efficient point. So if we now think about, well, what's producer surplus? Well, the marginal revenue or the price we're charging essentially becomes the demand curve. So the difference between that and the marginal costs, all of this surplus, all of total surplus from the perfectly competitive market stays the same. So total surplus is still the same as a perfectly competitive market, but it's now all producer surplus, right? So we would have kind of producer surplus of this price discriminating monopolist. What is consumer surplus? Well, I'm charging people exactly what their marginal benefit is. So the difference between the demand curve and the price they're paying, literally for every unit, would be 0, right? So we end up with consumer surplus being equal to 0. We get to that allocated efficient quantity. So we also have deadweight loss being equal to 0. Okay. So what are some of the kind of statements we can make? Well, if I'm comparing my single price to my price discriminating monopolist, notice the quantity that single price monopolist chooses is going to be lower than the quantity that the perfectly discriminating monopolist chooses. What will also be true is the producer surplus for a single price monopolist is less than the producer surplus for these price discriminating monopolists. Consumer surplus is actually greater when we're looking at a single price monopolist, because what is consumer surplus if we can perfectly price discriminate? 0. Right? And then deadweight loss for the single price monopolist. Well, the deadweight loss, if they can perfectly price discriminate, was equal to 0. So the deadweight loss here is something, it must be greater as well. Okay. So we can kind of compare these two different types of monopolists to each other. We can also kind of compare them to that perfectly competitive point. Okay? And it doesn't just have to be a constant marginal cost. The same things that we talked about at the end of last class would apply if we had increasing marginal costs as well. Okay. Any questions? So, and just to kind of point something out here. So notice what's happening is when I was charging a single price, every consumer in this range, right? I am able now to not just charge them this lower price, but exactly how much they're willing to pay. So I've like extracted some of their surplus, turned it into producer surplus. There's also people out here where they weren't buying it before, right? Their marginal benefit was below the price they had to pay. So they weren't buying it when I was charging a single price. Now that I'm charging them lower prices than that old single price, I've now convinced them to purchase this good. So I'm kind of gaining surplus as the producer from two different areas. Okay. All right. So if I can get my mouse back up here. There we go. Okay. So, I think I mentioned a little bit at the end of last class, perfect price discrimination is probably a little bit unrealistic. Although with as much information as companies are gathering on consumers now, via the internet, it's a lot, and people aren't buying things in physical stores as much. It's easier to kind of show consumers different prices or charge consumers different prices. Okay. So we can also think about this not just in terms of the identifying the consumers who are willing to pay more or less, but we can also think about it as like I'm charging the same consumer different prices if they buy more of this good. So let's assume instead of perfect price discrimination, we just had price discrimination. It's not perfect, just some. Just kind of make this point. Let's assume we had a single price monopolist. They would choose that quantity where marginal cost is equal to marginal revenue, go up to the demand curve, set the price. Here, if I keep marginal cost constant, well, if I have the same cost for every unit, in the long run, that will also be my average total cost. So really producer surplus with constant marginal costs and no fixed costs becomes the same thing as average total. So my marginal cost becomes the same as average total, but producer surplus would also be the same as my profits. So I could think about the difference between price and my average total cost, or my marginal cost here, times the number of units I'm selling. This would represent my initial profits. So 200 times 20 is 2,000. Sorry, that's bad math. 200 times 20 is not 2,000. We'd have what? 4,000. Okay. Sorry about that. I probably just copy and pasting. Didn't realize I didn't change that. So that's where we started out. Let's assume I can identify the first 10 consumers, and I figure out that, okay, they were willing to pay that price of 300, but they would have been willing to pay a much higher price. How do I figure out what price they'd be willing to pay? Well, wherever I'd be at on the demand curve. So if instead I identify those 10 consumers and charge them $400, well, those first 10 consumers are willing to buy the good at this higher price. So I've gained what? An additional 100 times 10, so an additional $1,000 from them, right? I was selling to them before, but at a lower price. So now I'm still selling to them, but at a higher price, I've gained some additional revenue there. What if I lower the price for the consumers between 20 and 30? Well, if I charge them that higher price of 300, their marginal benefit, the demand curve, was below that price, so they didn't buy it before. But if I instead lower that price to 200, now all the consumers from 20 to 30 would be willing to buy this good. Their marginal benefit is above that marginal cost. So I would gain some additional revenue by selling additional units now to those next 10 people, right? Even though I'm charging them a lower price. So we have the same kind of profits before from these first 20 units, but we've gained some additional profits from those first 10 people we sold to, and we've gained some additional profits from selling to 10 additional people over here. Okay, so we now have what? Profits would be 4,000 plus 2,000 or 6,000. Okay. So I'll come back to this, but if I want to compare kind of across these, like the extremes, single price, perfect price discrimination, perfectly competitive. In a perfectly competitive market, where would the quantity be? It's where marginal cost or the supply curve hits demand. However, this would also be the equilibrium price. So when I have a perfectly competitive market, the price is relatively low. Well, what's the difference between the price and the marginal cost? That's the producer surplus. So producer surplus would start out at 0. There's no dead weight loss. We're at that allocated efficient quantity. That means the entire area of surplus, the difference between the demand curve and my marginal cost curve. Well, we said in a perfectly competitive market, this would also be my price. So this would all represent consumer surplus, area A, B, and C. So total surplus would be A, B, and C plus 0. Right, so A, B, and C. Single price monopolist sets the quantity where marginal revenue is equal to marginal cost. They go up to the demand curve, set the price. So there we said we're losing all of these units from 100 to 200 here. So we now have dead weight loss. The producer surplus, the difference between their marginal costs and their marginal benefit, the price that they are charging, would be this area B. And then for consumers, the area above the price they're paying but below the demand curve, area A. So we only have total surplus of A and B here. We've lost out, or we have that dead weight loss of C. Now, if we can perfectly price discriminate, instead of like the single price monopolist, I can take all of what would be consumer surplus. I'm now charging consumers exactly the price they're willing to pay. I've turned A from consumer surplus into producer surplus. I'm still earning my producer surplus here. And then also, if I can sell at different prices, I can now sell to all of these people or all these units in between 0 and 2, or 100 and 200. And I'm now able to kind of eliminate that dead weight loss and turn it into producer surplus as well. Okay. So if instead I had something that looked a little more like this, that wasn't perfect price discrimination, what's that going to look like? Well, it moves in the same direction, right? So notice if I've got my demand curve, here's my marginal revenue curve, and I'll keep marginal cost constant just to make this a little bit easier, okay? So he said before, the single price monopolist, right? They were kind of setting this as the price and the quantity. However, we were looking at what if they can price discriminate, right? So I think in our example, we had 3 different prices. So this is like 10, 20, 30. And I think this was, I don't remember, doesn't necessarily matter. 300. No, this was 200, 300, 400. Well, if we think about where would producer surplus be, it's the difference between the marginal benefits and the marginal costs. The marginal benefits, the price, marginal cost, we've got our marginal cost curve. So for the first 10 units, I was charging that higher price of 400. Here was my producer surplus. For the next 10, I'm selling it at a price of 300. So here's my producer surplus. Now, this could not just be consumers. This could be if someone buys more than 10 of my product, I then lower the price they have to pay. So this is the idea of like a quantity discount. We see examples of this, buy 2, get 1 free. If you're doing like wholesale, if you order over 100 units, you can get it for a different price. And if you're, ordering 200, etc. And so then if I lower the price for the next 10 units, now the difference between the price and marginal cost will be right here. So producer surplus is still going up. So even if I can't perfectly price discriminate, producer surplus should be going up. If I am thinking about consumer surplus, it's the difference between marginal benefits and marginal costs to consumers. The marginal benefit is the demand curve, marginal cost is the price. So the difference between the price they pay and the demand curve for the first 10 units would be here. Difference between the demand curve, the price they pay for the next 10 units here, etc. So you kind of can notice what's happening to if I had like a single price monopolist. Well, all of this was consumer surplus. So even though by price discriminating, consumers gain some surplus here, they're losing this, right? Because we have linear demand curves, the area of this triangle would always be less than the area of that rectangle. So consumer surplus, when we price discriminate, will be going down. And then dead weight loss, with that single price monopolist, we had all of this be dead weight loss. Now, the only units we're not selling compared to that perfectly competitive point are going to be the units here. So what have we done by price discriminating? We've also reduced dead weight loss, right? we said with perfect price discrimination, consumer surplus and deadweight loss would both go to 0. If we're only able to imperfectly price discriminate, they're not going to go to 0, but they are going to be decreasing. Okay. All right. So just another way of kind of looking at that. You know, how much of this, plays out in the real world. I mean, we see this, you just don't think about it as price discrimination, but, dividing customers up by things like age. So for example, like senior discounts, student discounts for movie tickets or whatever it is, or like, you go to a diner, sometimes they'll have a senior discount. The idea there is, those groups, what does the demand curve represent? The ability and willingness to pay. So if you have a lower ability to pay, you have lower income, they know you're not going to be willing to pay as high of a price. That's why they give students and seniors discounts or essentially lower the price for them, right? They can sell to those some of those consumers where they might not have bought it before. Okay. Discount coupons are another kind of example of this, where essentially, I'm not necessarily charging a different price. You're paying a different price if you take the time to organize and clip these coupons. Who is going to be willing to do that? People who have a lower ability to pay. And so discount coupons essentially will lower the price for groups of people who it's worth the time to kind of use those, get those coupons, collect them, use them, etc. Okay. Now, another one you might not think of, but all of you probably aren't paying the exact same amount for tuition because of things like need-based financial aid. It's another form of price discrimination, right? We identify that some individuals aren't going to have as high of an ability to pay. They would still like to attend university, right? So what do? We lower the price for them. And all of these are examples of price discrimination. And then the one that I think of, we see a lot of is this idea of quantity discounting. And so a lot of times you might think, I use the example buy two, get one free. That's not, it's a little bit harder to think about that there's really a lower price for the third unit. It's kind of like you're thinking about the average price. I'll give you a better example. If you can kind of think about if you go into a gas station, so I've probably mentioned this before in the semester, but I have like a terrible addiction to Diet Mountain Dew and fountain drinks. So I go get one about every day. If you go to a gas station, you might pay like 79 cents for a 24 ounce of pop, right? Or soda. But then to get 36 ounces or 32 ounces, you're only going to pay 89 cents. So the first like 24 ounces, you were paying a lot more per ounce than for those next 10 ounces that you buy, or 8 ounces, whatever it is. And so quantity discounting, really, this is like, it's not necessarily the number that you're buying, but it's like if you have different sizes, you're paying less per whatever it is, per pound, per ounce, per, however you want to measure. I think popcorn in this example, right? Even though a large popcorn might be twice as big, they don't double the price, right? They only charge you $1 more because they know what's happening to your marginal benefit as you buy more of something. Well, in the popcorn example, if I really want some popcorn, the first handfuls I eat, that satisfies like my hunger, my taste for that. I had the highest marginal benefit for those first few handfuls. Eventually, I'm just going to have so much that, yeah, I like popcorn, but I'm already kind of full. I wouldn't be willing to pay near as much for the 10th handful of popcorn as I was for the first two. Or in my drink example, I want something to quench my thirst. I'd be much more likely to pay a higher price for the first 20 ounces than I would to have, the next, to go up to 40 or whatever it is. Okay. So we see examples of price discrimination out there. It's probably not going to be perfect. So maybe a little bit more like that last kind of model we looked at, but we will see it pop up, and we can understand what it's going to do to total surplus, deadweight loss, consumer producer surplus. Okay. All right. So the next topic we're going to talk about is thinking about a little bit of like a natural monopoly, but also this kind of movement between a monopoly and perfectly competitive market. So let's say I had a perfectly competitive market, right? I know that the quantity would be out here where if I have constant marginal cost, that's my supply curve. Supply is equal to demand out here. For the single price monopolist, they choose where marginal revenue is equal to marginal cost and then go up to the demand curve to set that higher price. So if I'm thinking about a monopolist, they've come up with put all this money into developing a new drug. If they can have temporary profits, temporary power on the market as a monopolist because of these patents, well, then they can earn a positive amount of profits, right? That difference between price, here constant marginal cost, which is the same as average total. So we would have like these profits. Now, once that patent expires, there's now a second firm who's competing. What happens? Well, I went to I went to some Benadryl yesterday. Benadryl was like $9, and the Kroger brand was $4.50. So which one do you think I bought? I looked at the back of the box. It's literally the same drug ingredient. So I bought the one that's cheaper, right? So if you have competition, once that patent expires, the other company undercuts your price. Well, then you want to undercut them so everyone buys from you. That competition exists until that price gets driven all the way down to that point where price is equal to that marginal cost, or we have profits being equal to zero of both firms. Okay. So as soon as we have another competitor, once that patent expires, we end up out of that perfectly competitive point. Well, this could be a problem because I haven't drawn in here, I'm assuming here that we don't have any fixed costs, right? I've just got this constant marginal cost. What do we know is true? Well, it takes a lot of money to develop a new drug. And so if I factor in the fixed costs, now my profits wouldn't be zero at that perfectly competitive point. It'd actually be negative. So we won't see that any firm finds it profitable to even invest into coming up with these new products, which is why we kind of give these patents to kind of guarantee if you put all this money into research and development, we kind of guarantee that you can have some monopoly power, charge that higher price, and kind of recoup some of those costs, right? With monopoly profits, okay? So that example, right, the reason why we would want to give patents to certain companies is because sometimes there are also industries where there's only enough demand given the current costs to support one firm. As soon as a second firm enters, we would actually end up seeing that at that perfectly competitive price, both firms would earn negative profits. If they're earning negative, what happens? One of them exits, we're back to one firm. So now they have positive profits. Well, we're kind of stuck there because if another firm joins, now profits are negative. One of them exits, we're back to one firm. So the idea there being, we had something like this, right? How do we regulate a natural monopoly? Right? So the natural monopoly would have a cost structure that looks something like this. Now, I kept marginal cost constant. I'll show you an example in a second where same thing applies if it's not. But where would the single price monopolist choose to set the profit maximizing quantity, where marginal cost is equal to marginal revenue, go up to the demand curve, charge this higher price, the difference between price and their average total cost times quantity, that would just represent the profits. Well, if another firm joins this market, we haven't quite talked about this yet, but I wouldn't face the entire demand curve. I would face half of it. So it would shift that demand curve down such that every point in the demand curve is below my average total cost. So when I go to set the price, even if I can keep acting like a monopolist, the new price would be below the average total cost. I'm going to have negative profits as soon as I have to split this demand with a second firm. So that's the idea of a natural monopoly. There's only enough demand. As soon as that second firm enters, we're going to have only half of demand. Each firm would have negative profits. One of them is going to exit. So there's only enough demand to support one firm, but that firm is still earning positive profits. So we know that if there's positive profits, we're seeing, well, where would the perfectly competitive or allocated efficient point be? Out where the demand curve hits marginal cost. So we've got all of this dead weight loss, okay? Now, the problem is if we try to regulate this market and say, well, look, we want to force this market out to the allocated efficient quantity. So I'm going to lower the price, or the regulation price is going to be down here. Well, what would be true if I tried to put it like, let's say, a price ceiling down here? Well, now at the kind of point where marginal cost hits the demand curve, right? The marginal revenue curve doesn't play a role anymore because I can't set the price. The government is setting the price for me. Price is below average total cost. This was the only firm. If price is below average total cost, profits are negative, they leave, we're left with nothing. What's deadweight loss? The entire market, okay? So what point can we set that would minimize, right? Keep this firm in the market, but lower their profits to zero. It's going to end up being this point where average total cost hits our demand curve. And I'll give you a depiction of this in a second. So we can't set price equal to marginal cost. We said if we do that, profits are negative, right? And the firm just leaves. We've lost the entire market. So we're going to try to set that price equal to that average total cost right where it hits the demand curve. Okay. Now you can have government ownership. We can talk about subsidies. I don't think we'll have time there to do that today. And I'm not going to ask you a question about how you would use subsidies to resolve natural monopoly issues on the quiz or the exam. But to be complete, that is a solution that if we had more time, kind of the next level, probably of an economics course, we would kind of dive into that. But for now, I want to kind of give you where is that optimal kind of regulatory price when we have these natural monopolies. So here I've got a demand curve. And let's say here's my average total cost curve. Here's my marginal costs, okay? So if I try to get out to this point, well, if I only have one firm, so the marginal cost is my supply curve. If I try to regulate it out to this point, price would be below average total cost, and I would lose the entire market, right? Profits would be negative, the firm exits, okay? Now, I know that if I don't regulate this market, they'll make decisions based off of a twice as steep marginal revenue curve. So what would be true here? The monopolist is going to set a price. It's above their average total cost. We have positive profits. So what if instead I start to say, okay, I'm going to put a price ceiling in right here, right? So pushes the kind of quantity out. We're up to right in the quantity here. So here is the quantity of the monopolist. The new quantity they would produce is out here. Price is still above average total, so they still have some positive profits. I'm going to continue to lower that price. All right, so this is kind of like my regulatory price until what's true at this quantity. Well, that's the point where price is exactly equal to average total cost, or I've driven the profits of the firm to zero. I know they're indifferent about staying or leaving that market. Right? So that's the lowest possible regulatory price I could choose where the firm would be indifferent about staying or leaving. So what do I probably want to do in practice? Try to set it like just slightly above that. But notice, what have I done? Before, with a single price monopolist, here was my deadweight loss. What is my new deadweight loss at that regulatory price? A much smaller area, right? So we're going to try to set the price equal to the average total cost where it hits that demand curve, right? That would be kind of the lowest possible price we could reduce this, the price of this good to where we would still have zero profits or the firm was indifferent about leaving. And then, like I said, in practice, probably want to guarantee they're not indifferent, that they actually do want to stay. So we probably set it just slightly above that. Okay. But when we're asked about identifying that price, right, we're identifying the point where it'd be indifferent. Okay. So I left that kind of open for that drawing. You know, this is just kind of summarizing. We know that the government tries to regulate monopolies. A lot of times they try to break them up because we know this deadweight loss exists. Okay. If it's a natural monopoly, we might have to resort to kind of setting that price equal to the average total cost, where the firm is earning zero profits. You could also see them subsidize these markets. Once again, we won't dive too deep into those issues. We're just going to kind of focus on that natural monopoly price being set equal to average total cost idea. And we can't simply set price equal to marginal cost. Otherwise, we said we'd have zero or negative profits and the firm would exit. Now the deadweight loss is the whole market. So sometimes instead of setting prices and worrying about this, what does the government do? It takes ownership. So if you go back to Postal Service, it used to be that the fixed costs were so high, right, that there was only enough demand to support one firm, right, trying to deliver mail across the nation. And so instead of trying to regulate this market with prices, the government just kind of took ownership of this. You know, problem is if the government has ownership, right, there's no profit motive. So the workers, maybe aren't as efficient or effective because they really don't have any incentive to try to earn profits because they know that those profits are simply going to, be eliminated, right? They're just going to The government's regulating this market, so there are zero profits. And then you could always do nothing. Maybe you see a natural monopoly. Hopefully, over time, demand increases enough that it can support two firms. Now you've got competition. You no longer have a natural monopoly, and you get that, competition drives the price down to the perfectly competitive point. But that's probably not, that's a solution, but it's probably not the greatest solution in most cases. Okay. All right. So I think we've talked about a lot of this. I'll kind of save this. We don't see pure monopolies. So usually it's not one firm having 100% market share, but we do see markets be really close to a monopoly. So like 90% of the market share is with one firm. So even though they don't have complete control over the price, their output decisions do still have some influence over the price, right? Another thing that we haven't really factored in here could kind of complicate these models even more. Having a monopoly is actually, in a way, a negative externality because it eliminates variety. And so if there's some value to society of having different, options for whatever this product is, we could factor in a negative externality into our market. And we see, oh, we're getting even, a higher quantity, of this good than we even want. And so you could complicate this quite a bit. If we factored in, maybe there's like an externality to a loss of variety because of monopolists. And then we'll talk a little bit more about markup. And I'll define this for us here in a second, but all that is a difference between price and marginal cost. And we can also think about almost every type of monopolist we've talked about here, there is some deadweight loss that's generated. The only time where there wasn't was when we had a perfect price discriminating monopolist, in which case, yeah, we eliminated deadweight loss, but we also eliminated what? Consumer surplus. Right? So, and the story is we don't really like monopolies very much. Okay. So before we get to this slide, I'm going to draw out, oh, there, I already went there. Something that's a little bit less going on in the graph to start out. So, and I think I kind of did something like this last class, but I didn't use the terms that I'm going to use now. So let's say I've got demand and I've got my marginal costs. Okay. If I only have one firm, that represents supply. I've got my marginal revenues. We said, where does the profit maximizing single price monopolist set the quantity? For marginal revenue is equal to marginal cost. They go up to the demand curve to set that price. Okay. So if we think about the deadweight loss that's created, we said the perfectly competitive point would be here, right? Where that quantity, where supply is equal to demand, that's the perfectly competitive quantity. So all of these units that the monopolist isn't producing, that was our deadweight loss. So one way of thinking about that deadweight loss is we said, what's the difference, or what's the base always going to be? Well, it's going to be the difference between the quantity that the perfectly competitive market would produce and the quantity the monopolist would produce. So you might not see this pop up in the reading, but once we get to module 13, we're going to refer to this as excess capacity. So it's the number of units that the firm could be producing that would still create positive total surplus, but they're not. And then what would the height of this triangle always be? Well, it's the difference between the price and the marginal cost of the monopolist. Sorry, I started writing marginal cost of the monopolist. So the height of that triangle will always be the difference between the price and the marginal cost for the monopolist. And then it's a triangle, so times 1/2. We're going to refer to this as our markup. Okay. So if this is our markup, right, if I have lower marginal costs, okay, what is that going to do to my deadweight loss? And I can also think about how's that going to impact kind of this markup here. Well, notice if I look at, I might draw this in the same graph here in a second, but if I'm just looking at my demand curve and I'm looking at marginal revenue. At different quantities, what is true about the difference between the marginal revenue and the marginal cost? That gap is getting larger and larger, right? The fact that this has a steeper slope, as I look at higher x-axis units, or I look at higher quantity, the gap in between these is going to be growing. Well, remember, I was setting the price using the demand curve, identifying the quantity based off of this marginal revenue. So if I have lower marginal costs, what's going to happen? So if I have lower marginal costs, I'm now going to be out at a higher quantity, right? But notice the gap in between the quantity and the perfectly competitive quantity, that gap is going to be getting larger. The fact that this is twice as steep, that gap is going to, so our excess capacity is going up, right? We're producing even fewer units relative to that perfectly competitive point. And what's happening to our markup? Well, that difference now in between price and marginal cost, it's also getting larger. So when we have lower marginal cost, assuming that demand stays the same, and this is, some of this is intuitive. If a firm can lower their cost but face the same demand and they have monopoly power, well, their costs are lower, they're going to produce more than they were before. However, right, they're also going to be able to earn higher profits, or essentially the difference between the price that they're charging and what it costs them to produce it, that gap, that markup is also going to be getting larger. Now, the not so intuitive result is they're producing a higher quantity, but if they were perfectly competitive, they would produce an even higher quantity. That gap is going to grow in between that perfectly competitive and that monopoly quantity. Okay. So really what I wanted to kind of get at here, about as far as I push you on the quizzes or the exam, is just the idea of what's happening to the markup. Right? I won't ask you about excess capacity here. I wouldn't even ask you necessarily about deadweight loss, but I think it's worthwhile to think about when the costs of these monopolists are lower, they can increase their markup. What's that increase in markup going to do? It's going to generate more deadweight loss for society, but it's going to generate larger profits for the monopolist, right? So we can kind of think about, I've got something in the slide that goes through this. So if I have my marginal cost initially equal to marginal revenue, here I set the price, here's the quantity. If I can lower those marginal costs, the new optimal point, marginal revenue equals marginal cost, is out here. Go up to the demand curve to set the price. Hopefully you can kind of see, having this drawn to scale, that markup has gotten larger, right? The price, right, maybe that they charge is actually a little bit lower, but their markup, they don't care if the price is higher or lower. What do they care about? Increasing profits. What's going to kind of be tied to increasing profits if I can get that markup, the difference between price and my marginal cost and my marginal revenue, to be larger. And then you can kind of notice what could be the case. If I had my average total cost curves in here, well, if I calculate profits, here was my initial profits. What are my profits after this price change? Or sorry, this marginal cost change? Well, now it's this even larger rectangle. So we see that when we can lower our costs, right, we're going to increase that markup, but we're also going to increase our profits. And then we said increase deadweight loss as well. Kind of notice before, deadweight loss was just here. Afterwards, it's here. So because we're increasing that markup, and when we calculate deadweight loss, we said the base of that deadweight loss triangle will always be the markup, we're going to see our deadweight loss increases as well. Okay. All right. So puts us with about 30 minutes remaining. I think we'll go through some, well, actually, I didn't go through this participation quiz. This hopefully should be very easy based off of what we've already talked about. So we already did the price discrimination stuff. So this is almost kind of just rehashing it. If I wanted to find the profit maximizing quantity, if I can perfectly price discriminate, I don't make decisions based off this twice as steep marginal revenue curve. My demand curve, we said I'm charging different prices, so that becomes my marginal revenue curve. So if I can perfectly price discriminate, the point where the price that I'm setting, that marginal revenue, that's my demand curve now, is equal to marginal cost, would be out here at a quantity of 22.5. Okay. And then if I wanted to calculate what is consumer surplus, we said if I can perfectly price discriminate, at every quantity, the price I'm charging my consumers is exactly equal to their marginal benefit. So we said consumer surplus there should just be 0. Right? And then, excuse me, if I wanted to calculate deadweight loss, we said, well, the point where the perfectly price discriminant monopolist will go to is that quantity of 22.5. If this is the only firm, their marginal cost would be all of supply. So supply would be equal to demand, or that would be the allocative efficient point that maximizes total surplus is at the same quantity, which means if we've maximized total surplus, our deadweight loss should also be 0 with perfect price discrimination. So I meant to go through those kind of at the beginning. We covered all those topics, but the actual questions here, I wanted to make sure we kind of went through so you had those answers. Okay. All right. So a little bit of review once again. And this is just, there's a problem like this on the practice problems. So kind of this one here, right? And we'll kind of come back to this one since I think it even would be a little bit easier. But I'm going to do this all in Excel to kind of give you a more complicated example. If we can understand the complicated one, the more simplified, smaller kind of table should be a little bit easier. Okay. So let's say I gave you all this value with total revenue, didn't give you total revenue. I gave you total costs, and I gave you the combination of price and quantity. So if I give you price and quantity, what did I really give you there? I gave you the demand curve. So if we wanted to find total revenue, so let's ultimately say, here's this monopolist, here's their total costs, and here's their demand curve that they face. Okay. So if I want to identify the profit maximizing quantity, right, I need to figure out where marginal revenue is equal to marginal costs. Okay. So how do I find marginal revenue? I first need to know what's total revenue. Well, total revenue is just going to be price multiplied by quantity. So I'm doing all of this in Excel. You would just be typing this into a calculator, right? And, I'd have to 76 times 8. But in Excel, if I use these cell references, when I copy this down, it kind of does that for me at every single point. Okay. So we'll notice here, as quantity was going up by 8, how much was the demand curve going down by? Going down by 4. So essentially my slope there was what? Negative 0.5. So what should the slope of my marginal revenue curve be? Every time I go up by 8 units, instead of falling by 4, it should fall by 8 or have a slope of negative 1. Well, how do we calculate marginal revenue? It's just the change in total revenue. So take my new revenue minus my old revenue and divide it by the new quantity I'm producing minus whatever the old quantity I was moving from was. Okay. So change in total revenue divided by a change in quantity will just give me my marginal revenue. Now, when I copy this down, what should be happening to my marginal revenue? Right? We said that initially, not initially. We said that as we kind of preserve, our marginal revenue is twice as steep, so it should be going down just like the price was, but instead of going down by 4, it'll go down by 8. Right? So I've done this correct. At least it's following all those principles so far. If I then want to say, okay, where's my marginal costs? Right? So my marginal costs are going to be the change in my total costs. So take the new total costs minus the old total costs, divided by a change in quantity. So new quantity minus my old. Now I could do this by hand with these values, and I'd have to do it for every single quantity and price combination. So like here, that would be a little bit more work if I can't do this in Excel. But if we're in Excel, once I get the formula in there once, I can copy it down, and it does the same for all the future cells. Okay. Excuse me. So I can just looking at this identify, okay, where is marginal revenue? The last quantity where it's greater than or equal to my marginal costs. So it looks like it's right here at that quantity of 56, price of 52, because if I go to 64, what's true about my marginal revenue? It's now below my marginal costs. Okay. So this quantity price combination should be where the single price monopolist would kind of choose to produce. Now we can prove this to ourselves by calculating profits. So there's two ways we can calculate profits. The first is simply going to be take my total revenue and subtract my total costs, right? Now, hopefully when I copy this down, what I'll see is that as I produce more, my profits are increasing up to this point. If I go past this point, they're decreasing. Okay, yeah, that's the profit maximizing quantity and price combination, right? Now, I could also find my average total cost. That's just my total cost divided by quantity. The other form of the profit equation we had was take the quantity I'm selling, multiply that by the difference between the price I'm charging and my average total cost. So we have two ways we can calculate profits. Hopefully, both of them give us the same value. Otherwise, I've been lying to you. Sure enough, we get the exact same values. That quantity of 56 is where profits are at their highest. Okay. Any questions over anything? Yeah, up to there. So I want to say something here. So I'm not going to expect you to do anything in Excel, but just to kind of show you like a thing that you could do. So we have things called if statements. So if I like didn't want to look at these numbers, or it's maybe I had like 200 different price quantity combinations, I could do this little if statement where I say, okay, look, I want to identify the last quantity where the marginal revenue is greater than or equal to marginal cost. So if the marginal revenue is greater than or equal to my marginal cost, comma, put in the word, yes, I should produce. If it's not, put in the word, no, I shouldn't. Okay. So if I were to use an if statement like that, if I had a lot of different values, I can, okay, yeah, where does it stop saying yes? Okay, that's the last quantity it says I should produce. I shouldn't produce any quantity past that. Okay. And then we could do some different things for the perfect competitive market. There, instead of comparing marginal revenue to marginal cost, what are we doing? We're comparing kind of where that price is equal to that marginal cost, or where my demand curve hits the marginal cost. So we could do a similar thing there as well. For the sake of time and getting through some more problems that'll help you on the quiz, I'm not going to build the rest of what I have over here. Instead of yes and no, I think in the completed one, I put ones and zeros just so you can kind of quickly identify. But I do think it's worth kind of thinking about this as well. So you can identify this price quantity that maximizes profits. What would the break-even price be? So this is like where would profits be equal to zero? So we said, well, this doesn't really apply to monopolies. I don't want to go back and do perfectly competitive stuff today. We're focusing on monopolies. If we have some time, maybe even on the review day, I'll kind of go back into this file. We'll do some of the perfectly competitive stuff. It's not going to be, tested in terms of using Excel in the quiz or exam. So I'm not overly concerned with that. One thing I do kind of want to point out, though, as long as we're here, and this could help you with the quiz and the exam. So let's say I think about, remember last class we said, I can figure out if demand is elastic or inelastic based off of the marginal revenue. So I could just look here and say every time my marginal revenue is positive, we said that told us that the demand curve was elastic. And then everywhere where it's negative, that would be where it's inelastic. Right? So here, my marginal revenue is positive for all of these quantities. And then it becomes inelastic for all the quantities down here. Okay? So once I've identified marginal revenue, I've technically also identified, am I on the elastic or inelastic portion of my demand curve? Okay? So we'll relate this to a problem here. We'll eventually kind of get down to thinking about questions 6 and 7. I'll add a question in here. So if I were to take this, right, I'm going to insert a column, insert another column. If I want to know the marginal revenue of the third unit here, well, I first have to find total revenue. That's simply going to be, just like we did in the Excel file, price times quantity. So 0 times 18 is 0, 1 times 15, 15, 24, 27, 20, not 5, 24, 15. How would I find marginal revenue? Right? That's a change in total revenue divided by a change in quantity. So can't really find marginal revenue at a quantity of 0. Now here I have nice quantity changes of 1. So the change in my total revenue is 15 divided by a change in the quantity of 1. Marginal revenue would be what? 15. Then it goes up by 9. Then it goes up by 3, -3, -9. Now, if I had jumps of like instead of 1, I went from like 10 to 20, it'd be the same process. It's just now it would be the change in total revenue 15 divided by 10, so 1.5. Okay. So just because I gave you an example where you have jumps of 1 here, don't forget that denominator, it won't always be a change of 1. It's whatever that change in the quantity demanded is. So the marginal revenue of that third unit is 3, which tells me that at that unit, the demand curve is elastic. If I instead had a marginal cost of 9, where would the marginal cost be equal to the marginal revenue? Well, now that's at a quantity of 2, but if marginal revenue is still positive, that's telling me the demand curve is elastic. Okay, so using a table like this, you can figure out marginal revenue. If I then give you, and this is what I would do, give you a nice, easy, constant marginal cost, and here it's 9, I could figure out where marginal revenue is equal to marginal cost. As long as that's positive, I know that the elastic, the point I'm at in the demand curve is elastic. Now, we said that the single price monopolist will always choose a positive marginal revenue. Let's think about instead, what if I had a perfect price discriminating monopolist? Okay, and let's say I add a question in here. So I say like the price discriminating monopolist faces marginal cost, constant marginal cost equal to 6. Okay. Well, remember, they're not making a decision based off this twice as steep marginal revenue curve. Their marginal revenue curve is simply the price. So the point where that marginal cost of 6 would be equal to their marginal revenue or the price would be down here at a quantity of 4. So notice the perfect price discriminating monopolist can actually choose a quantity and price combination where the marginal revenue, if they acted like a single price monopolist, would be negative, which means they'll end up on the inelastic portion of the demand curve, right? So kind of to review that idea, how is that the case, right? So we said here, anytime I have a demand curve, there's going to be a point where it's unit elastic. Every point up here will be the elastic portion. Everywhere down here would be the inelastic portion. What will end up being true is when my marginal revenues equal to 0, that is the unit elastic point. Anytime my marginal revenue is positive here, elastic. Anytime it's negative, inelastic. So as long as I have costs above 0, where would the single price monopolist choose? Where marginal cost is equal to that twice as steep marginal revenue curve, go up to the demand curve, set that price. So the single price monopolist will always be on the elastic portion as long as we have any marginal costs. Now, what can happen if I'm perfectly price discriminating? Well, there, the supply curve, right? There's one firm, marginal cost represents the supply curve. I'm setting my prices, so based off the demand curve or the marginal revenue of the price discriminating monopolist is the demand curve. So where is their profit maximizing quantity? They're out here. Notice what's true about marginal revenue at that quantity. It's negative. So we can see that perfect price discriminating monopolist end up on the inelastic portion of the demand curve if the marginal costs are are a specific value, right? Doesn't always have to be the case, but it can be the case. Okay. Any questions here before actually, no, that said, no, it would have to be the case in the models that we're using. Okay. And then just to kind of carry out with this little setup of problems. So go back, I didn't ask you about if it was elastic or inelastic. The actual problem 7 was if I do perfectly price discriminate, what is the marginal revenue? Well, we said marginal revenue, if I'm price discriminating, is simply the price associated with those different quantities or the point I'd be at in the demand curve. So if I'm looking at that third unit, I could charge consumers a price of 9. That would be my marginal revenue. And then we know that if I'm practicing perfect price discrimination, I'm always driving the dead weight loss down to 0. Okay, so we would be kind of right here. Any questions on that before we keep moving? Okay. Let me see if there's anything up here I wanted to mention. Dun, 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 dun. Well, I know I want to make sure that we get through problem 12. So if we have time, I'll come back and maybe go through those quickly. But I really want to make sure we go through question 12 because I don't think I've really drawn this out for you, but we have all the pieces of information, all the tools we need to answer a problem like this. So which of the following is not true? If I've got a monopolist, and I definitely make sure I'm much more careful, unless I tell you it's a price discriminating monopolist, assume that it's a single price. But I'll make sure, like on the quiz and exam, I always write in single price or perfect price discrimination or perfect price discriminating monopolist to really make sure we're aware. So single price monopolist, which of the following is not going to be true if demand increases? Okay. So let's draw this out. All right. And I'll draw it with a constant marginal cost just to kind of helps solidify this idea. The same thing would be true if we had increasing marginal costs. So let's say initially I'm starting out, I've got this demand curve, and I've got a twice as steep marginal revenue curve. Okay. So I choose that profit maximizing quantity where marginal cost is equal to marginal revenue. I go up to the demand curve to set that kind of monopoly price. Now, with constant marginal cost, we said that ends up being the same as my average total. So that was helpful because we could think about producer surplus, the difference between price and my marginal cost, is the same as the difference between the price and the average total cost times the quantity I'm selling. This represented producer surplus or profits, right? Those were kind of one and the same when I had constant marginal costs. So if I see an increase in demand, right? So this parallel shift, I try to draw these as parallel as I can without using a ruler. So I've got, well, those aren't parallel, but it's okay. We'll run with this example. Now, I should have had this drawn in a little bit steeper, right? Because it's so. Trying to make sure these are more parallel. Okay. So where would my new optimal quantity be after that increase in demand? Well, marginal cost is equal to marginal revenue here. I go up to the demand curve to set the price. Now my profits, the difference between price and average total cost times the quantity I'm selling, or producer surplus, or my profits are now going to be much higher. So anytime I have a demand increase, because that demand and marginal revenue, it's kind of similar to what we talked about before. If I'm looking at higher quantities, when that demand and marginal revenue curve shift up, the gap in between them is going to be getting larger. So I'm always going to see that when I have a demand increase, the quantity that the single price monopolist chooses will go up. The price they charge will always go up. And we're always going to see that the profits also then increase, right? This black to this red area. And then the exact opposite would be true if I ever had a demand decrease, right? We would just see quantity goes down, price goes down, and profits go down. Okay. Now, when I'm talking about things that increase or decrease demand, what we've always done in this class is we're assuming that it's demand shifts, right? So that's why it was important that I had the lines drawn parallel, because it's not a change in the slope of demand, it's that it's shifting demand, right? If for whatever reason that relationship between price and quantity demanded changes, well, that's a different story. We're just thinking about if I saw something that increases the demand curve, but kept the slope, right, that relationship between price and quantity demanded the same. Sorry for, that's why I had to kind of cross that one out. It wasn't parallel. Okay. All right. So just running through a few more questions to kind of hopefully help with this, the quiz scores and the exam. So I've got the exam kind of written, waiting, ready to go. There might be some questions that seem easy, right? And there will be some easy ones on the quiz and on the exam. So here, if I have a single price monopolist, right, kind of told me here, what's the optimal profit maximizing output and what will the profits they earn be? I mean, I've said this, I think you probably are getting annoyed hearing me say it, but they set the profit maximizing quantity where marginal cost is equal marginal revenue, so 15. So right away, if I'm taking like an exam, I can cross these out right away. Okay. I know the profit maximizing quantity for monopolist will be 15. And then what is the amount of level of profit? Well, it's the difference between the price I'm setting, which is 24, go up the demand curve, the difference between the price and my average total cost times the quantity I'm selling. So 24 minus 20 is 4 times 15 should be $60. Okay. What would the dead weight loss be that exists? Well, where would we be at if we were in the perfectly competitive market? Well, our monopolist marginal cost, if it's one firm, their marginal cost would be all of supply. So if the perfectly competitive market gets to the point where supply is equal to demand, that would be out here at a quantity of 25. So we're underproducing by 10 units. Every single one of those units, we're missing out on the surplus or the area in between demand and supply, or demand and that marginal cost. So it would be the area of this triangle here. So what? 24 minus 12 is 12, times 25 minus 15, 10. So 12 times 10 is 120. But then remember, when you're finding the area of a triangle, multiply it then by 1/2. So 120 times a half would give us that 60. So this kind of goes to our earlier point. If we were looking at the level of output that satisfies allocative efficiency, so this was going to be the point that a perfectly competitive market would get to, or a perfectly price discriminating monopolist would get to. The allocative efficient point is going to be where total surplus is maximized. So that's where this marginal cost or the supply curve hits the demand curve. At that point, what is true about my marginal revenues? Well, there my marginal revenues would actually be negative. Right? So if I have negative marginal revenues, what point am I at on this demand curve? I'm going to be on an inelastic portion of the demand curve. Okay. Also, another thing to point out here, if this was a monopolist and the government tried to regulate this market by setting the price at 18, would that actually be the point that minimizes deadweight loss? If I lower the price to 18, what's true now about my price relative to the average total cost? It's below. So the profits would be negative. What will that firm do in the long run? Exit. That was only one firm. I've lost all firms. I've lost the entire area of surplus. I have the highest deadweight loss possible. So I don't have a dashed line in there, but where would I want to be lowering the price to? Looks like it would have to be like right about like 19 here, the point where profits would be equal to 0 and the firm would be indifferent about staying or leaving. Okay. And then if I had the perfectly price discriminating monopolist here, how would I find kind of profits and the quantity they would sell? Well, we already said perfect price discriminating monopolist, their marginal revenue curve becomes a demand curve. So we're back out at that allocated efficient quantity of 25. And then what would profits be? Well, here the idea of profits is going to be a little bit different, because this kind of the equation that we had when we took price minus average total cost, that was assuming one price. All bets are off if we have price discrimination, because I'm now setting different prices for every single unit. So if I was out at that point where marginal cost is equal to demand, what would my profits be? Well, at every unit, here's the price, the demand curve is the price I'm charging. Here's my marginal cost. So if I were to calculate producer surplus, With a price discriminating monopolist, that would actually also just represent monopoly profits. Okay, but that only works if they're perfectly price discriminating, where producer surplus and profits will be exactly the same. Okay. At least when we have these increasing marginal costs. Okay. So that would be what? The entire triangle there. So it'd be what? 30 minus 4, so 26 times 25. If you have a triangle, so times a half. I think if you do that, you'll get 325. Okay. All right. Any questions? Should kind of wrap it up here a little early. A couple more things to say before I finish the recording. So you have that participation quiz we ran through for today. I'll put up that module 11 quiz as soon as I end class. I'll kind of get it added in under this heading. So the module 10, 11 quiz and the 4 participation quizzes from earlier this week, all due by the end of the day on Sunday. Okay. We'll start module 12 tomorrow. So that module reading is due before we start class tomorrow. And then we'll kind of start module 12, finishing up on Monday. I'll assign the module 12 quiz. And then module 13, we will do Tuesday and Wednesday, assign that module quiz. And then those 2 quizzes for module 12 and 13 will do the end of the day next Thursday. We'll do reviewing class next Thursday. And then next Friday, we'll have that final exam, similar to the first 2 midterms, kind of in that 4-hour time block. You can get on, start anytime that works for you. And we'll talk more about the details of the final as we get closer to it next week. Okay. So I'm going to end the recording there.